Welcome to the Explainer. Today we're going to embark on a bit of a quest to demystify computer science. We're going to break down the fundamentals and show you that it's way less about scary, cryptic code and a lot more about a really powerful way of thinking. So here's our map for the journey. We've broken our quest down into 5 main stages. We'll kick things off with the call to adventure to figure out what computer science really is. And we'll wrap up by setting you on your very own path to mastery. All right, so every good adventure has to start somewhere, right? For us, it's got to be the biggest question of all. What exactly is computer science anyway? When I say computer science, what pops into your head? For a lot of people, it's this image of someone furiously typing weird lines of code on a dark screen. But is that really the whole picture? Here's the thing. At its very heart, computer science isn't really about the code. It's a framework, a method for solving problems. Just think about it like this. You have an input. That's your problem. You run it through some kind of logical process, a black box, and you get an output. That's your solution. That's really it. It's the art of tackling problems in a methodical way. Okay, so if it's all about solving problems, how in the world do we actually tell a computer our solution? Let's peel back the curtain a little and see what's actually going on inside the machine. This is kind of wild when you stop and think about it. Everything you do on a computer, sending an email, watching a video, playing a game, to the machine itself, it just looks like this, a massive endless stream of zeros and ones. That's it. That's the only language it actually understands. So how does that jumble of ones and zeros, magically turn into something we can read, like a simple hi? Well, it all comes down to what's basically a secret decoder ring that we all agreed on a long time ago. It's a standard called ASCII, and it just assigns a number to every single letter and symbol. So the number 72 always means H, 73 always means I, and so on. The computer just has this chart memorized. And this idea, this is the key to everything. It's a concept called abstraction, and it's probably one of the most important, most powerful ideas in all of computer science. It's just the magic of hiding all the messy, complicated stuff. It's what lets us type hi without having to think for a second about the millions of zeros and ones making it happen. All right, so you get the language, you get the concept of abstraction, you're ready. It's time to actually give the computer some instructions. It's time to tell it what you want it to do. But let's not even start with code. Let's start with a problem we can all wrap our heads around. Imagine you've got this gigantic, million-page phone book, and you need to find just one name inside it. How would you do it? I mean, you're not going to start at page 1, are you? Of course not. You'd do something way smarter, probably without even thinking about it. You'd open it up right to the middle, see if you're close, and then you'd literally throw away half the book you know you don't need. And that logical, step-by-step process you just came up with, that's an algorithm. And when you write it out like this in plain English, that's called pseudocode. See? You're already thinking like a programmer. And here's the really cool part. You can take that exact logic and turn it into a working program without typing a single cryptic line of code. There are tools out there like Scratch that let you build programs just by snapping together colorful blocks, kind of like Legos. It's an amazing way to get started. Okay, so we've got the logic down with blocks. Now let's level up. It's actually a much smaller jump than you might think to go from those friendly blocks to powerful text-based code. So let's imagine a super simple program in Scratch. All we want is for this little cat to meow 3 times. Easy enough, right? You just grab a repeat block, tell it 3, and pop in a play sound block. Done. Okay, now for the translation. On the left, you see our simple Scratch blocks. And on the right, that's the exact same logic in a language called C. Now I know it looks way more complicated, but stick with me. This for loop thing is just C's fancy way of saying repeat 3 times, and printf meow is basically how it says play the meow sound. The idea is identical. It's just the grammar or syntax that's different. And look, it's totally normal for that code on the right to look a little intimidating at first. But as Professor David Milan from Harvard puts it, even though they look cryptic, they all share common ground underneath. And the reason they're so similar is that almost all programming languages are built from the same handful of ingredients. You've got variables to store stuff, loops to do things over and over, conditionals to make choices, and functions to keep your code organized. Once you get these 4 ideas, you can learn pretty much any language out there. So with these core ideas, you've basically got the essential toolkit. You can turn almost any idea into a set of instructions. Think of it like you've just finished the tutorial level of a huge video game. The real adventure is just beginning. Seriously, once you grasp this stuff, problem solving, abstraction, those core building blocks, it's like you've been handed the key to this massive treasure chest. You've unlocked this whole universe of technology to explore. And this is your treasure map. These are just some of the amazing territories you can now go explore. You want to build smart AI? You can do that. Create secure systems? Yep. Design unbelievable computer graphics? You have the foundation for all of it. The possibilities are just huge. So, you've answered the call, you've learned the secret language, and now you're holding the map. There's really only one question left to ask yourself. What problem are you going to solve first?